Hello. We are now at evaluating expressions, and we will finally uh, walk through our abstract syntax tree and evaluate the expressions. So to do that, the first thing we need to do is add an evaluate command, like we had other commands in our uh, interpreter. We are going to add one more command in the main class called evaluate. So let me just copy this, add Control V, and it's gonna be evaluate, and we will call the evaluate method. So let me create that. And in the evaluate method, everything is going to be essentially the same, but just instead of serializing it with the AST printer class, we will call the interpreter class, interpreter, and let me create an object of it, interpreter, new interpreter, and interpreter dot uh, interpret. So we need to create this class. We're going to create this class where in the analysis, yeah, I'm going to create an interpreter right here. Interpreter. And inside of this interpreter, we're going to write all the code to interpret. But in my runner, I need to import it. And let me create this method in the interpreter class. Do I need to add anything else here? I don't think so. I think we are good. Okay, so let me do one thing. And I wanted to return an object. And if result equal to null, we will print nil. And if that is not the case, we will just print the result. Okay. All right, now let's finally get to the interpreter class. So in the interpreter, this is going to extend, it's going to implement the expression visitor of type object. And let me implement all the methods. Okay, so the easiest thing to do right here is visit the literal. So this visitor is basically like an in-order traversal. This interpreter will receive an expression, and right here we will return e dot accept this, and this will call the required method on it. You know the visitor pattern, right? So right here what we can do is in a literal I can simply return, oops, my bad, dot value. That's all we need to do in the literal node. But literal basically means we are at the root of the abstract syntax tree, right? So at the root we simply return the value. We do not need to traverse anymore. So in ternary we have a condition, and it's ternary dot condition, and based on if the condition is something, if condition, then I need to visit the true branch, return ternary dot true branch dot accept this. Similarly, this also will be accept this, else return ternary dot false branch dot accept this. That's what we need to do here. How do ternary statements work? Ternary statements, all right. So if I write true question mark and 1, 2, this results in 1, right? Because true is true. But what happens if I write 1? And what happens if I write 0? So 0 is essentially false, right? So 0 typecasted to Boolean would be false and 1 typecasted to Boolean would be true. Similarly, an empty list typecasted to Boolean, like in JavaScript, is false, but a non-empty list is true. So there are some values that are truthy and some values that are falsy. 0 is falsy. Similarly, 1 is truthy and empty list is falsy and a list that is non-empty is truthy. So instead of checking on the condition, I should check if the condition is truthy or not. Is truthy, and I'll send it the condition. So what do you think is null? Is null a truthy or a falsy? Null is again a falsy. So if the condition it's receiving it's null, in that case we will simply return false. If condition is equal to null, we will return false. And if the condition is an instance of Boolean, in that case we are quite clear what we need to do. We just need to typecast it and return it. Boolean of condition. But if that is not the case, if we receive anything else, so right now we're not giving this. Right now we're not supporting this. So if we receive anything that is not a Boolean, so right now in logs only nulls are falsy. So that's what this means. We're going to return true from here because only nulls are falsy in logs. Okay, so is truthy is used like so. The next thing we're going to do is visit the grouping node. So a grouping is quite simple. All we need to do is expression dot accept this. That's all we need to do in a grouping expression. Above the grouping expression, we have a unary. So let's implement the logic to visit a unary now. So how would a unary be evaluated? The first thing we need to do is evaluate the right hand expression. So uh, expression dot right dot accept this, and then we have two operators in a unary, a negation and a bang. So let's switch on those. Switch expression dot operator, and if it is equal to minus, in that case we're going to return a minus, and we will typecast it to double and right. And if this typecast fails, then the expression was wrong. So I don't want to throw an error. This will throw an error. It will throw a typecast error, and that's what I want to happen. And the other operator is a bang. Let's import it. And in case of bang, so a bang negates the true to false and false to true. So it also works with falsies. So a negation of null would be as a null is falsy, a negation of null should be true. So I will use the is truthy method we created just now. So negation of is truthy, and I will send it right. All right, and right here, if we receive any other operators, then we know if we are doing something wrong. Return null, that should not happen. Any other operator is not allowed. Switch statement does not cover all possible input values. Create default branch. Do I need default branch? Default return null. Okay, we don't need it right here. The default will work for us. Switch expression. Fine. Now what is it saying? What the hell? Control Z. Control Z. I don't like switch expressions. Anyways, this is the unary method. Now, similarly, binary is simple as well. We have a left and a right expression. Object left is equals to expression dot left dot accept this, and then we have a right expression, right, and there can be different operators for binary as well, right? So we need to add all the binary operators right here. So we will switch on expression dot operator and case. Let's handle the minus case first. So it's quite simple. We know what to do. We need to typecast them both to double of left minus uh, double of right. Now this typecasting might fail if the left hand and the right hand expressions do not uh, if the value of this left and right cannot be typecasted to doubles, this will throw a case, and that's what I want to happen. I don't want this operator to work on those values. So right now we're not handling those errors, and it's required of us in the later stage, handling runtime errors, and we will do that later, but right now just keep it simple. So that's the minus operator. And what do you think will be in the plus operator? Will it be just uh, a plus? No, it won't be, because the plus operator works for concatenation as well. So we need to handle that as well. So in the plus, I will check if left is an instance of string or right is an instance of string. In any of this case, we need to do concatenation instead of a double addition. So all we need to do is plus left plus right. But if that is not the case, in that case we need to do this. We need to do the double addition. So let's just do that. And the other operators are division and multiplication. Will be quite simple. Star, we will multiply, and we have division, that is slash, let's divide. What other operators are there that are binary operators? We have comparison. All right, so let me add those as well. Let me create another case for greater. For greater, all we need to do is check if it is greater. So right now the greater only supports doubles, not strings. Similarly, we have greater underscore equal, and for greater equal all we need to check is greater equal, and we're going to have less and less equal. So you can add support for comparison of strings as well right here. It will be quite simple. Java does that by its own. So since we are utilizing Java in the backend, the we just for to support strings, all we need to do is drop this typecast right here. That's it. What's the issue? Why is it throwing an error? Remove switch branch greater equal. Duplicate greater equal. Acha. Less equal, for less equal, all we need to do is this. What other operators are we missing? We are missing equality checks. So we need to add two more cases for equal equal and bang equal. Bang equal, and another case for equal equal. For equal equal. So for bang equal and equal equal, we are going to support string comparisons as well, and uh, Java does that for us. So all we need to do is use the equality operators of Java, and that will work. So for equal, I'll create a utility method is equal, and I will pass in the left and the right to it, and we're going to create this method. And for bang equal, I'm going to simply negate the is equal, pass in the left and the right. So in the is equal method, so if the logs language supported implicit typecasting, like in JavaScript, when you compare anything to a string, JavaScript automatically typecasts the other thing to a string as well. If you wanted your language to do that as well, this is where you would do it. This is where you would typecast left to a string if right is an instance of string, or typecast right to a string if left is an instance of string. But we don't want logs to do that, so what we will simply do is uh, we will check if left is null and right is null, because null is not equal to null. So but it should be equal to true for logs. That's why we're adding this check. If left is null or right is null, then we know both are not null, so both cannot be equal. So we will right here return false. And for any other case, we can simply do if left dot equals of right. I think that should be it. Cast expression to a boolean. Wait, boolean? Yeah, is equal will return a boolean. Okay, what is the error here? Let me check the error. What is switch statement does not cover all possible inputs. What is missing here? Let me add a default case default branch. Uh, Unexpected value. I think that is fine. We'll keep that for now. Let me just try to push and see if it works. We will call it evaluating expressions. Let's see if it works. Tests failed. What is the issue? Build failed. Cannot be converted to lexicon.token. Interpreter line number 39. 39 dot operate. Oh shit. Operator dot type. My bad, guys. I'm so sorry. Don't need it anymore. And similarly, right here, dot type, and we do not need this. Control X, and we'll return the null from out here. What is the error now? Missing return statement. Where are we missing a return statement? So right here, if we receive any other operator, we will return a null right now. We will handle those runtime errors later, because they're asking us to do that in the later stages. Let's see if it works. So instead of writing these switch cases, what you can do is you can, like we have an expression visitor, you can create an operator visitor, and we can simply pass in the operator to that operator visitor, and it will call the required method on it. So we can create methods that do this logic and this logic in the operator visitor, and we don't then this because I don't like this switch case, it's very cumbersome, it doesn't look pretty, but since the logic is quite simple, we have written it in line. But if you wanted to, you can actually create an operator visitor anytime you see a switch case and different logic being dispatched on the case. In that case, you can write a visitor pattern on it. Anyways, it works. Let's move on to the next stage. So I'll keep clicking continue, and I will come back if I see any error. But if we don't, all these stages should pass. If we don't have any error, all these stages should pass. I do think there is going to be one error in the next stage. So wait, I think there is going to be, let me check. So the error is right now we convert it to a double. So it will be printed as 10.0, and that's not what we want. So let's see the error. As you see 46, it's printed 46.0, and we only want to print 46. So to do that, in the runner class, let me come to the runner class. Yeah, right here. In this else block, we need to check if the object is an instance of double. All right. So if the result is instance of double, in that case, I need to check if, but if it's not an instance of double, I can simply print it out. But if it is an instance of double, I need to check if I can strip the decimal from it. So double D equal to double, I'll typecast it to a double. And what I'll do is I'll check if the integer value of this double is equivalent to D. So if D dot int value is equal to D, in that case you can strip. So what I'll do is I will typecast it to an integer, or I can simply do D dot int value and I will print it. I will print val instead of res. But if that is not the case, I will print the result, or you can print even D. Alright, I think that is fine. Let's try to run it again. Yeah, it works. So now I'll keep on clicking continue, and if I see any error, I will get back to you. But if you don't, hopefully all of these stages should pass. So our code was fine, all of these stages passed. This is the final equality operator. After this, we are going to handle the runtime errors. Like I told you, we are doing typecasting, right, in our code. We are typecasting the object to double quite a lot of times. So if any of those typecast fails, in that case, that is a runtime error that we need to handle, and that we will do in the next video. But that's it for this one. I'll see you in the next one. Guys, we're actually missing something. Right here in the parse method, you see we are checking if expression is not equal to null. But what if the parse method threw an error? If parse method threw an error, we were setting this some twos not be equal to null. We were setting a value for this parse exception. So before actually printing the AST, we should also check if parse expression is not equal to null. And we should only print it if that is the case. Similarly, we should only evaluate an AST if the parse exception is false, is null. So if it's not equal to null and the expression is not equal to null, only in only in this case we should go ahead with interpretation. Otherwise, we should stop the interpreter. We should not interpret the code that is wrong.